So far we've been dealing with double ampersand for and double pipe for or, and these are for saying if this condition and this condition is true, do something. In the case of the or, it says if this condition or this condition is true, do something. Now we're going to be using is bitwise operators, and these are not being used for conditions. These are going to be used for dealing with devices. So let's quickly go through the AND table here. And the concept here is to get a 1, you basically have to have both inputs 1. For an OR, to get a 0, you have to have both inputs 0. Let's take a look at our exclusive OR, which is a little down here. It's a little different. And to be exclusive, you've got to be different. So, for instance, if two women show up wearing the same green dress, fashion disaster 0. If two women show up wearing the same red dress, again, fashion disaster 0. To be exclusive, you got to be different. So a 0, 1 and a 1, 0 are the only ways to get output here of 1. Now, if we take a look back here, this can be looked at a little differently because when we start dealing with hardware, and the hardware can be, say, 8 switches, or it could be 8 LEDs or something that's 8. And we'll see that as we look at our program later, that's why we're using char, because char is 8 bits. But if we take a look here for a mask bit, we're going to be taking a look at masks. If a mask bit happens to be 0, if this is a 0, my answer is 0. If this is 1, my answer is 1. So it doesn't matter whether it's a 1 or 0, my output's going to be a 0 if my mask bit is a 0. If we take a look here for an AND function, if our mask bit is a 1, then if this is a 0, my answer is 0. If this is a 1, my answer is 1. So the bit will actually come through completely unchanged. So the mask bit of 0 goes to 0, mask bit of 1 comes through unchanged. Now if we take a look at the OR, if our mask bit here is a 0, if this is a 0, my answer is 0. If this is a 1, my answer is 1. So if a mask bit for an OR is a 0, then whatever the bit is comes through completely unchanged. However, if our mask bit here is a 1, if this is a 0, my answer is 1. If this is a 1, my answer is 1. So if the mask bit is a 1, whatever I have as an input to the other bit will come out as a 1. So what we're going to find is the AND function is used to basically, as a single bit operation, is used to selectively clear bits to 0, and the OR function is to selectively set bits to 1, and we'll see the application of that shortly. Now if we take a look here, the exclusive OR, the way it works here is if our mask bit is 0, a 1 with this is going to give us a 1, a 0 with this is going to give us a 0. So again, with a 0, the bits are going to come through completely unchanged. But this is kind of interesting. This is a little different. If I put a 1 here, if this is a 0, I get a 1. If this is a 1, I get a 0. So it's actually going to flip or toggle a bit to the opposite state. So let's take a look at a very simple C program. As I mentioned, 8 bits, because we typically would have, say, these could represent 8 switches. So unsigned char A equals this number 0B for binary. So these could be indicating switch on, off, on, off, on. And this would be our mask byte to indicate that, we want to look at certain switches, but we don't want to look at other switches. As we said, if this is a 1, notice this pattern that we've got up here, 1101, is going to come floating through. Putting zeros, complete new masks offer makes the output here 0. And that's our single bit AND. Notice there's just a single ampersand. Now if we're doing an OR here, then if we take a look and treating this as an OR, and this again is our mask, what we're going to find is that these zeros here mean that for our OR, the 1011 comes floating through. But all of these numbers here, no matter what it is, because 1 turns it on, means all these are 1. So this is going to selectively set these to 1 and let this come floating through. In the case of the AND, though, it's the opposite. Now let's take a look at the exclusive OR, which is kind of interesting. So if this is our mask byte here, what it means that all the bits up here are going to be completely inverted, and these are going to come through completely the same. So if we take a look here, this is 1101. So our output here is 0010, which is a complete inversion of this, but the 1011 comes through unchanged. Now if we look at the inverse function here, what it means that every 0 goes to 1 and 1 goes to 0, so this is a complete invert of this. Okay, here's our program, and what we're going to do is we're just going to run it using F5, and it's going to bring up our DOS screen, which we aren't really using as output. I'm just going to slide up here and hit our pause button. What I'm going to do now is just zoom in just a little bit, and let's take a look at our variables. Now you can see what's in the variables just by hovering over. So in binary, 1101111 is dB, and if I hover over the B, it's F0. And this is our original number, this is our mask, and we can see here that we're doing this number here, dB, ANDed with F0, and our answer here is going to be D0. And what you can see here is I've actually done that in binary. And also here again, the same number dB ORed with F0 is in this case going to give us, if I hover over here, FB. If I slide down here and do an exclusive OR, I get 2B, and if I look at the invert, I get a 24. Now to terminate our program, all we have to do is, there's a couple ways to do this. We can either hit our little button here, or we can do Control C to get ourselves out. So I'm just going to hit the button here to get us out.